Okay. So what is the concept of big data? What are the different V's are there? So I just talk about this. Okay. Okay. First thing is what is big data? Okay. So big data is a framework. Okay. It's a framework for analytics of large amount of data. Okay. Analytics of large amount of data. So data could be like a very, very large amount. It could be a GBs, TBs, petabyte, exabyte. Okay. So large amount of data. So how can we measure that the data is a big data? So there are some characteristics are there. So one characteristic is the velocity. So when the data is coming very fast speed, velocity is very high. So data is called big data. So velocity is the speed. The speed the data is generating. Another one is velocity is there, and volume. So volume is proportional to velocity. So volume is automatically high if, so in the big data, when we are talking about these characteristics, velocity, volume. So volume is high when the velocity is high. Okay, so volume is high, depend on the velocity. So if I just take an example of one flight, which is like for 30-minute flight. Okay, the 30-minute flight uh, from one place to another place. So it is generating 12 terabyte data. So we can say in this minimum time, right, this data is very huge, right? So velocity is high, then the volume will be high. Okay. So velocity, volume, and one is veracity. Veracity is like when we say like the data is correct, because if data is not correct, it's no point to measure the data. It's no point to analytics of the data. So veracity is truthfulness of the data. The truthfulness of data, that is called veracity. Okay. So data should be correct before doing the analytics. Okay. So that is the veracity. So data should not have the null values, missing values. So we cannot do the proper analytics. Another characteristics is the variety. So data is coming from the different sources, right? So we can say the data is coming audio, video, okay, picture, text data, files data, okay, art, database data. So there are so many varieties are there, right? Data is coming in different forms. So next thing we will see, right, what types of data are there. This is also characteristics of the data, right? It is talking about when we call it big data, right? So when we are looking at these characteristics in the data, then we can say the data is called big data. Okay. So variety is a different form of the data is there. So whatever data we look at around, right, social media data, audio, video, picture, right, text file, images, right? So all these data are the like a big data, right? Basically the data is different form of the data. So next thing is how many types of data is there? How many types? So one is structured data. Okay. Because before going to implement the analytics, right, to work on the big data analytics, we need to understand the scenarios, like where we have the data, big data is there, and then we can do the analytics. Okay. So how many types of data is there? Structured data. Okay, structured data is the data which is a fixed dimension, the fixed dimension. Okay, some examples of the structured data is like I say, text data is there. Okay, number data is there, date is there, age, right? So these are all example of structured data. So RDBMS data is structured data. RDBMS data is a structured data, because this data is, we can easily measure this data, structured data, and we can measure this data easily, right? We have fixed dimensions are there, we can measure the data. But when I talk about unstructured data, so unstructured data is like audio, video. We don't have traditional tool like we can measure it. Like we need some image processing APIs, audio processing APIs, video processing APIs. So we need some separate APIs, right? We need it, right, to measure this kind of data, unstructured data like audio, video, images, okay, pictures, right? So these data are called unstructured data. Another category is data is there, semi-structured data. So what is semi-structured data? Like semi-structured data is data which is a combination of structured and unstructured. Like if I say email is attachment, right? So attachment is a image, right? Attachment is an image, and that is unstructured. Okay. And when I say in email, there is a subject, body. So those are the text data. These are the text data. So this data is email. Email is a semi-structured data. And another one examples of semi-structured data like CSV file, JSON file, CSV file, JSON, XML, because we know all these types of files, right? In day-to-day life, we use these files, right? CSV, JSON. So there is a fixed delimited character is there, like CSV is a comma, JSON is a key colon value type data is there. XML is like nodes are there, like I say EMP node is there, EMP node having the ID is there, and ending tag and starting tag is there, starting tag and ending tag is there. So so why it is unstructured? Because if I say the data is a structured type is there in the file, but file itself is a unstructured. Okay, file is a unstructured, but data in file is structure type. That is the reason it is called semi-structured. So these files are called semi-structured. Okay, so we have different tags are there in XML. Okay, this is a XML format. Everybody knows about the XML. So we can have starting tag and ending tag is there. Okay, so these are the characteristics of the big data and types of big data. Okay, now we see like why we are having some traditional tool which we are not able to do very large analytics of the data. Okay, if I talk about why we come to the big data, why big data came into picture. Okay, so the first reason is like we have some traditional tools, right? I say I have RDMS database or this one. The main problem is the very large amount of data, how to measure it, right? Because if I say scalability is a one bigger factor, scalability. Okay, what is scalability? If I say I have a one machine, okay, and I have my machine capacity is 2 TB data. So how much data I can maximum store in this machine? Only 2 TB data. And I say this machine has 64 GB RAM. Okay, 64 GB RAM, 2 TB hard disk. Okay, and I say I have a 16 cores machine is there. This machine is having the 16 CPUs core. Okay, 16 core CPUs. So if this machine has some limitation, beyond this limitation, I cannot store the data. I cannot process the data. I can not use the data for further storage because its capacity is there, its limit is there. But if I'm creating some cluster, I'm creating some cluster where I have a 10 nodes are there, 10 nodes, and I say each node having the 2 TB disk, 64 GB RAM, 64 GB RAM and 16 core. So 16 core CPU is there. So how much capacity of this cluster I will say? So if I have a 10 node and 2 TB machine, so my total disk size will be 20 TB. My total RAM 6400 GB, 640 GB RAM, 640 GB RAM. And I say my 16 core multiply 160 cores. So this is my cluster strength. So this is called horizontal scalability. So horizontal scalability is where you can add as many as number of node in your cluster. Okay. So why we need horizontal scalability? Suppose today I'm processing only 2 TB data. So this machine is enough. Okay. But suppose tomorrow I am having a 5 TB data, 10 TB data. So I need to make it a cluster. So cluster is basically a combination of nodes and where the capacity of the cluster is all the total nodes of capacity. Okay. So this kind of scalability is called horizontal scalability. So if I talk about any RDMS database, if I say RDBMS database, so these are the vertical scalable like MySQL, Oracle, okay, and SQL Server, any SQL database. But when I talk about the NoSQL database are like Mongo, Cassandra, HBase. So these are the NoSQL data, CouchDB. Okay, so these are all NoSQL databases. These are the horizontal scalable. So Hadoop is also horizontal scalable. So Hadoop is a framework. So Hadoop is an implementation of the big data. So Hadoop is a framework or implementation of big data. Okay. So basically what we needed, right, for there are two things are there. We need a storage and we need a processing. Okay. So why we need storage? Because once we do the processing, we want to store on the some storage, right? And further processing, we need storage. And whenever we want to process, like we will use a processing. So these two things we needed in any system, in any framework that can be provided. So Hadoop is a framework which is providing a storage and which is providing the processing component. Okay. So storage is provided by the Hadoop SDFS. So Hadoop SDFS is a Hadoop distributed file system. So it's a similar type of file system. It's a tree-based file system. Tree-based means it's a tree-based structure. It's a sequential file system. And it is a file system similar to the Unix and Windows file system. It is same like a Windows and Unix file system. But there is a big difference is this file system. Okay, one is how we measure the data in the file system. Like initial limit, like we can start with the KB, MBs, okay, and then we say GBs, then we have TBs, like this we say, correct? TBs, okay. But before the KBs, we have the block, right? We call it some size we fix and then we call it block. So this block is nothing but like in the Unix and Windows file system, this block size is 6 KB. One block is 6 KB. Okay. So whenever I say like I have 100 KB data is there, so 100 block I will like 100 divided by 6. When I say 1020 1024 MB's data is there, like 1 GB data is there. So I will divide it and I will find the number of blocks. So Unix and Windows, they put it a very less size of the block. So number of blocks will be more. But Hadoop file system, the block size is more. The Hadoop file system, the block size is 128 MB. The Hadoop 2.x and 3.x default block size. 2.x and 3.x newer version of Hadoop. So there is the block size is 128 MB. So why they designed the block size too much large? Because if we compare it, the Windows, it's very large block size, right? Because the reason is when we are processing the large amount of data, so if our block size is more, so we have less number of blocks and it will be faster to read less blocks rather than having a more number of blocks. So the design of the Hadoop file system, they have thought about it before designing the Hadoop file system. The block size should be larger so that whenever the file is very large, is there GBs, TBs, petabyte, so they can process that much file without any problem. But in Windows, if more than 100 MBs file is giving a problem, right, to open a file in the notepad. Okay. So the reason is like Hadoop file system, the block size is larger, and because less number of blocks will be giving a good performance. Okay. So the storage component is SDFS, and the one processing component they provided MapReduce. Okay, so MapReduce is basically the two component is there in MapReduce, map and reduce function. Okay, I will talk about more in the map and reduce. So some more concept we just go through it, like what is what are the Hadoop features. Okay, so Hadoop is open source. First of all, like open source, anything is open source, then there is a no cost, right? Because you are developing your own implementation framework based on the Hadoop. So your cost will be very less, right? Very less cost, right? Because the Hadoop is giving, it's an open source. And second thing is, it is flexible. Flexible is like it supports a different types of data. It supports different sources of the data. Support different sources of data. So that is the reason it is flexible, right? So it is flexible, like it can handle structured data, semi-structured, all type of data. like structured, semi-structured, unstructured means all type of data it can handle. So it is flexible. Okay. Another thing is there in Hadoop is it's a reliable. Why is reliable? Like now I'm having a question of high availability. Okay. So my Hadoop cluster has 10 nodes, right? And if I say one node is down, if one node is down, so how Hadoop will be taking care of that? So how Hadoop will taking care of that, right? If one node is down, so how Hadoop will taking care? So there is a replication factor, right? Replication is there. So whatever data you have in one node, it is replicated 3 times. So that is called replication factor. So Hadoop has replication factor. So replication factor is there, then reliability is there. So replication factor is like, suppose I have a one block in one node, that is replicated in 3 nodes. The same block will be replicated in 3 nodes. Okay. So that is basically the high availability is there, reliability is there. So reliability, flexibility, and economical. So economical means like if it is an open source, so definitely it is a economical. And one more thing is Hadoop is having a master slave architecture, master and slave architecture. So what is a master slave architecture? Like Hadoop is saying one master node that is called name node. Okay. I'm talking about in the SDFS. So SDFS is 2 component is there. SDFS 2 component. One is a name node, that is master node. Name node is a master node, which is containing metadata. Containing metadata. So metadata is data about data. So whose data it is containing? Data node data. So second component in SDFS is data node. So data node is a second component in the SDFS, and that is slave. Okay, that is slave. So suppose if I'm saying 10 node cluster is there, so how many master node will be there? One master node, that is name node. Okay, and 9 are the data node. Those are the slave node. Okay. So here is why they kept it master slave. So in master slave architecture is one master is controlling to all slaves, right? So if any slave is down, any data node is down, so master will replicate the data. Master will be assigning the another data node. Suppose I'm a client, I'm a user. Okay, I'm a user and I'm saying to Hadoop file system, I'm storing some file in SDFS. Okay. So I will request to whom? I will request to name node to find node where I can store data. Node where I can store data. Okay. Store data. Then name node will check its metadata. Okay, its metadata and find relevant node to client. Okay, and then client will start writing the data. Okay, while writing the data, and client will start writing data into data nodes directly, because all the IPs it got it from the name node. Okay, while writing data, suppose one data node goes down. So name node has responsibility. So name node is doing some heartbeat mechanism, heartbeat mechanism with data node. So all slaves are having a heartbeat mechanism with all data nodes to check continuously every 10 seconds. Every 10 seconds, it is checking every 10 seconds, checking any data node is down or not. Any data node is down or not. If it is down, if anyone is down, it will assign another data node. Suppose client is using the data node and that data node is down. So name node will assign another data node to client, for writing data. okay, writing data. So this is like a mechanism is there. Okay, so here name node is having all the information about the data node, and all IPs are there. And whenever it found any data node is failed and it is not able to it's not giving any signal back to the name node, so it will assign another data node. Okay, so for data net point of view, we got the high availability. But suppose if name node goes down, so name node is a single point of failure. Name node is single point of failure. What is mean? Point of failure. If name node goes down, entire cluster is down. There is no point to communicate to the data node, because name node is a single entry point. If that name node goes down, then we cannot connect to the cluster. But Hadoop has provided the solution for that. So Hadoop has provided solution for name node failure. For name node failure, there is a secondary name node is there. Secondary name node. So secondary name node is same as backup name node, and it is active and syncing the metadata, because secondary name node has to sync the metadata, because it should have the same copy of metadata which name node has. If that name node has backup data, syncing the metadata is there, but the same backup data is not there in the secondary name node, so we cannot get my request fulfilled. My request will not be fulfilled, right? So one problem about the secondary name node is there. It is syncing the metadata. It is active and syncing metadata every 30 minutes. 30-minute times it takes to syncing, 30-minute time. So we can assume it like if name node goes down and secondary name node is becoming active name node, so this secondary name node 30-minute is late, right? So my 30-minute time before request will not be processed, like just 30-minute after. Okay, so I need like in Hadoop 2.x, this was a concept in Hadoop 1.x, this secondary name node. Okay, secondary name node is in the 2.x also there, but in the Hadoop 2.x and 3.x, they have given advanced concept, the standby name node. So Hadoop 2.x and 3.x, they gave standby name node concept, standby name node. Okay, this is also providing high availability in Hadoop 2.x, and it is passive name node. It is passive name node, and it will active within a minute. Within a minute means it's not a big problem, right? But more than minute, right? Like 30 minutes, that is really a big problem. Okay, but it is passive name node. It will become active within a minute. Within a minute, it will active. And there is a one quorum node. Quorum node is there. That will be quorum node in between passive and active name node. Passive and active name node. Active name node. So it will be syncing the data. It will be syncing data between active to passive. Between active to passive. Okay, so suppose your active name node down. Active name node is down. Name node is down. Then this passive name node will become in a minute time. Name node will become active. Okay, this is a concept clear, right? Will becoming active. So all these things will come later more and more in deep. Okay, but this is a fundamental architecture idea about why we are going to the Hadoop, right? What is the features of Hadoop? What are the characteristics of Hadoop? And what is like two core component of Hadoop, SDFS and MapReduce. Okay, SDFS and MapReduce. And SDFS is further divided into the two parts. So SDFS is your name node and data node that I already explained you. And MapReduce is a job tracker and task tracker, name node and data node. And MapReduce is for the two component are there, job tracker and task tracker. So same concept is here also. Job tracker is a master and task tracker is slave. and job tracker is allocating the task to the task tracker. So every data node is there one task tracker. So you can say if I have a 10 node machine, so one node is master, that is my name node. Okay, and one same node I have job tracker, same node I have job tracker. Okay, other 9 nodes, I have data node and task tracker on same machine, data node and task tracker. So in Hadoop 2.x, one change came, I tell you, that is yarn architecture, yet another resource negotiator, negotiator. And this concept is basically this job tracker, they change it to name as a resource manager. Okay. Earlier, job tracker work is to just allocate the task to the task tracker and taking care of the responsibility of managing the task tracker. But in 2.x and 3.x, okay, in Hadoop 2.x and 3.x, they have given more responsibility to the job resource manager. So job tracker is changed to the resource manager, and task tracker is changed to node manager. Okay, so I will explain that what is a Hadoop 2.x and 3.x, the yarn architecture. What is this yarn architecture? So they have done some changes at the side of processing component side. They have done the changes. Okay, so in storage side, still the name node, data node, and secondary name node are there. The total 5 services are there. So when we install Hadoop, total 5 services will come. So 3 services are for storage. What are the name of the services? Name node service, data node service, and secondary name node service. Okay, and this is storage, and 2 services for processing. 2 services for processing. So one is resource manager and node manager. Okay. So when we are installing the Hadoop, right? When we install the virtual box, okay, and we install virtual box. In the virtual box, we will install the Ubuntu, and in Ubuntu, we will install the Hadoop. Okay, and once we install Hadoop, automatically we will get the 2 component SDFS and MapReduce. Okay. This MapReduce is nothing but combination of resource manager and node manager. So this SDFS and MapReduce, these 2 will come automatically. Okay, when we install the Hadoop. Okay, and then we can, in SDFS, we will write the command. I will show you how to use the Hadoop commands. So Hadoop developer command, right? Whatever Linux command we use, same command we use in the SDFS Hadoop developer command. Copy a file, remove a file, delete a file, or like there are so many commands are there, 30-40 commands are there. So Hadoop developer command. MapReduce, we have a Java program, like we write a Java code for MapReduce. So entire Hadoop is based on MapReduce concept only, map and reduce. Okay, so entire Hadoop is internally, and this Hadoop is written in Java only. So this Hadoop itself is written in Java, some API, Java API is written in Java API. So Java code is written. The backend, SDFS, Hadoop, MapReduce, everything is written in the Java. Okay, so when we are running this, we have to install VirtualBox, Ubuntu, Hadoop, and then we have to practice for the Hadoop command, and then MapReduce Java program. Okay. So I will give this notes. So basically, you have to start when you are starting the like this notes, right? So here is what are the main key factor comes, right? Like privacy, security comes, right, in the place, right? Security is there, province is there. These are the general terms. Okay. Here is big data starting here, the big data life cycle. So analytics life cycle is like, first of all, we are getting some case, right? Business use case. Like suppose I'm in the banking domain, insurance domain, or automobile, anywhere, right? If you say any domain today is using big data, because big data is a need, right? Because every domain has a very, very huge amount of data. They cannot use like ordinary Java or Python programming So even this Hadoop is using the programming language Java, Python only, but it is based on the cluster, right? Distributed computing based on the distributed computing. Okay, because our data is not on one machine. Our data is hundreds of thousands of machines are there, and we have to take care the data. So we cannot do manually. One by one machine, we cannot do the measurement of the data, analytics of the data. So we have some sophisticated tool, right? Like Hadoop, Spark, Kafka. Okay, so these are the tools provided, and these all tools only from one particular machine to we can control whole cluster. So that machine is called edge node. Okay, so suppose I have a 10 node machine cluster, 10 nodes machine cluster, and all machine having SSH. All machines are doing SSH connection. SSH connection means one machine I can connect to another machine by SSH connection, and then this is a network. This 10 machines is called in a one network, and one machine is called edge node. Edge node is an entry point, like for any command or anything you control entire cluster by this one machine. Suppose you have 200 nodes in your cluster. So one machine can control entire. So everything is installed on this machine. So you will be installing the softwares here. Even the software you need it on all machines. Like all these 10 machines, you have Hadoop. Without having Hadoop in all machines, you cannot communicate, right? But edge node machine is a entry point machine where I can write my command. This is like a server. It is like a gateway server, and companies providing the access of this product. So they will not be giving you the access of entire cluster, because automatically you will get the access of entire cluster by this gateway node. Okay, so providing access to entire cluster by this gateway node, entire cluster by accessing gateway node. Okay, so this is called edge node. Okay, the another name is edge node. Edge node is a place where you can log in and then you can run your command. So what is a life cycle? Like you got some business use case, you have the data identification, right? You found the data, what type of data it is. Because if you're dealing with the data, so you should know what type of data format is there, right? It's a CSV, JSON, XML, or so many other different format data is there, which is supporting by Hadoop, Parquet, ORC, Avro. Okay, so there are n number of formats are there. Okay, and once we identify the data, we have acquisition and filtering things. Some data extraction we are doing, validation we doing, cleansing we doing. This is complete life cycle of the data. Then finally data analysis. This is our big data part, data analysis. So here we are doing the transformation thing. So data analytics means transformation, join, aggregation, functions like, or we are doing other transformation like union, intersection. So many transformations are there, but depending on the business use case scenario. Once your data analysis is done, then finally you will visualize the data. You will be doing reporting. So reporting of the data, there are some other tools are there. For every step, there are different tools are there. Here we are using Spark, Hive. Okay, so these are the analysis tools. But before ingestion of the data, other Hadoop tool are there, like Scoop is there, Flume is there, right? Visualization, Power BI is there, Tableau is there. These are the visualization tools. And finally, you once get your result in your report, and then you can publish the report. Okay. So here is, these are all steps, like you can go through it. This is just basic fundamental concept, right? How each step, what you are doing in each step and what you are processing in the each step. So this is just general use case scenarios of big data, like where you using the big data. But when you start further things in the big data, so you start with that. So different types of V's. It is not given a complete book. I'll find it the complete book. So here is a like here is this all these things are there, like SQL, no SQL, right? You are using, and storage part, right? We are talking about the storage. So SQL, no SQL will come, okay, for storage. And batch processing or cluster. What is a cluster? What is a map reduce is there? So map is there, partitioner is there. So these are the map reduce concept. And some other things are These are machine learning or those things are there. Okay. So any questions so far? First, like I will. Anybody has any question? This is just fundamental only, basic concepts. So installation things, what we have to do, first we have to download, if everybody has Windows, right? So we download the virtual box, we go to the virtual box, download. So here the 7 version is there, Oracle virtual box site you go. So here is 7.0 release is there. So this one we can download it, and then we download the Ubuntu ISO. So Ubuntu ISO like 20.04 you can download Ubuntu desktop. Separately you download this Ubuntu 22.10, any version you can download. So Ubuntu, this one ISO image you can download, and once your virtual box is installed, so you will get like this virtual box. So here you have to create a new machine, new, and here you give your virtual machine name. Here you give the ISO path, where is your ISO file is there. Okay, and then you will be going next. Okay, I just show this. So suppose you are giving your virtual machine name one. Okay, like this, I given my Ubuntu. You can give any name, and ISO image. So this is ISO image path. Suppose my ISO image is here, and I'm selecting it's a Linux version or Unix version. Okay, it's automatically taking because Linux and Ubuntu 64. And next, I have to select the user password here, right? I have to give my virtual box user password. Okay, so I can set it here, my user password. So you can set it this. Next, you have to set the memory. So my system has 64 GB. Okay, but you can select how much RAM is there in your machine. If it is a 12 GB RAM, so 8 GB you can give. If you have 8 GB, then 4 GB you can give. If 16 GB is there, then 12 GB you can give your virtual box. So this memory will be used when you will be using this virtual box. Okay. Otherwise, if you are not using your virtual box, so entire RAM will be used by the Windows. So once you take in a RAM, and you can increase the processors also, right? How many processor is supporting you can give. Next, you can select the disk, right? How much disk size, right? So you can select the disk here. Minimum you give 100 GB. If you have 250 or 500 GB, so you can give 50 GB minimum. Okay, and then you finish it, and then you start your cluster. Okay, when you start here, here you will get the run button, like you can click on that, and then you can start your Hadoop this virtual box. So it will start installation of Ubuntu. Okay, once this Ubuntu is done, then you can log in your Ubuntu. Like this, you will get your user and password. So once you enter here your password, you can enter into the Ubuntu. So once you come into the Ubuntu, so this is my Ubuntu. And once I come here, so next thing is I have to install the Hadoop here. Okay. So installing the Hadoop, there is a very predefined steps are there. We need a Java first. We need a Java. Or if you can do the Google Chrome also, because Google Chrome is not coming by default with the Ubuntu, because you have to separately install this Google Chrome. You have to install it. So Google Chrome, you can install it. Google Chrome, you can install it you can install it. There is a, okay, how to install it. Actually, command line you can do from Ubuntu. So there are the steps are there. Google Chrome you can directly install on Ubuntu. So you can download the Debian image or this Chrome image. So you can download it and then you can run the command. When you come to the Google Chrome website, so there is this Debian image, you can download it. Okay, so that is a one way. Okay, and other way is like using the wget command, you can also download. Okay, that is the second way. Install Google Chrome through the command line. So here is this wget command you run. Okay, after that you run this one, Debian package, you run it. And once you run it, your this here the Chrome will come. if you click here and type Chrome, so your Chrome will appear here, and then right click and add into the favorite. Okay, so Chrome will come here. So this is the way to install the Chrome. So I will give the steps in the notepad. Okay, so this is just only step one. Just download the wget command, wget download this Debian package, and then run this Debian package. Okay, so this one, and how to install the Hadoop. So there is a link, Hadoop installation Ubuntu. Mine is already installed. I cannot show, but I can install anybody's machine, right? Okay. On Monday, I will install it. You can guys try, and but you have to keep it ready, your virtual box and Ubuntu. Then only you can go to the next step is Hadoop. Okay. So this Phoenix cap is there. This Phoenix cap, Phoenix nap, right? .com, right? If you go this one, so here is clearly steps are there for installing the Hadoop on Ubuntu. So here, first of all, you need a Java 8. Okay. So Java 8 we need to install because it's a fresh Ubuntu. Nothing is there. So we have to download sudo apt update we have to do. After that, we have to install JDK. So you have to copy the command and run it. So it will install your Java. Mine is already installed Java. So I can see the version. So when I see on the terminal, Java -version. So I will get my Java version. So mine is Java is already installed, but you guys can download the Java, install the Java by using this command, sudo apt install openjdk 8. So Java. So basic need is the Java, right? We can go for Java 11 or Java higher version, but I think Java 8 is good for any installation because it will not create any problem. So you can verify your Java version, and after that you have to install the OpenSSH, because OpenSSH is like you don't need to give password again and again. To avoid password giving again and again, so we have to make it password SSH less. Okay, so OpenSSH server and OpenSSH client we have to install, and once this is done, this part you don't need to do. You don't need to create a Hadoop user. Directly we have to do in our own user. Like this is my own user, right? Like I say Arvind is my user. So everything you have to do on this prompt. When you do this here, everything you have to do on this prompt. Okay, so first you do sudo apt update. Okay, it is asking my sudo password. So it is updating my Ubuntu. It is updating. Okay, so once this sudo apt update you do, then after you have to do the Java JDK. Java you need to install. Okay, so you have to install Java, and then password this OpenSSH server and OpenSSH client. This step you don't need to do. This one you don't need to do. Add user you don't need to do. Directly you come to the passwordless SSH, right? So this is SSH keygen command is there. This command, then you will run this command, then you will run this command for the giving permission. After that, you will check SSH localhost. So when you do SSH localhost, so you should get the connected. So here my SSH is connected. So I'm not getting any error. If you are getting any error means your SSH is not done properly. Okay. So mine is already done. That is the reason I'm not getting any error. Okay. And next is you have to download the Hadoop. So this is the official website of Hadoop web page. There you have to go to the Hadoop website and download the latest version. So here is 3.3.4 that is released in 2022 August 8. Okay, so this binary you have to download. So either you click this binary or copy this link and do wget command. So what they are doing, they are using wget command here. So if you see here, they are using this wget command. So this wget command, they are doing this star.tz file. So wherever you want to copy it, you download it, and then you have to extract it. So the thing is, this extract command is tar xgf, and whatever version is there, you have to extract it. So first of all, what you have to do, you have to create in your home some software folder. I have already created software folder, and here I can start my terminal, and I can say here wget, and then I can give the command. Okay, so mine version is same. If you see 3.3.4, and this is also 3.3.4. So I downloaded here in software folder, then I did this command tar xgf. Okay, so once it is downloaded done, then you have to do the next command is tar xgf, and then whatever version is there. So my version is Hadoop 3.3.4, and then it will extract the Hadoop. So you will see your folder will be look like this. Okay, so here the first thing what I need to do, the first thing is I have to open the bash rc file. It is hardly 5-minute thing. Okay, if your steps are done properly, Hadoop will install in 5 minutes. If your steps are missing or something you have not properly configured, so troubleshooting may take 2 hours, 3 hours, or maybe entire day. So if 5 minutes, if you are following properly, then it will be done. And this is the bash rc path, right? All the Hadoop. So everything we have to check it here, because this path is, I have to change here, because I have to change here /home my username, because this Hadoop home is my user. So I show you this bash rc path. So this bash rc you will get it. This bash rc you will get it, your home folder. Here you will get it. nano.bashrc. So if you go to the bottom, so I have already added this one. So can you see here the difference? /home Arvind software Hadoop 3.3.4. So here you have to set this your Hadoop home. This line you have to set it. And here is a one equal sign is required. Okay. So I have already in the notepad, I will send you those notes so you can follow. So here you have to change, and here you have to change. And once after this done, next thing is, this is they are displaying here also, like here. Okay, and here is a equal is missing. Okay, just take care of that. Equal is missing, and here is your username will come. Once this is done, so next command is source command you have to run. If you have not run this command, so whatever changes you have done in your bash rc, it will not be reflected. It will not be reflected. And next, the configuration file change you have to do in etc folder, in Hadoop home etc folder. Here your configuration files are there. The first file is Hadoop env.sh, this file. And this file you open in the editor and add this Java home. Okay, so it is given in the instruction export Java home. As it is, you have to copy paste it. Next file is nothing to do else, core site.xml. Core site.xml is a file. This is a core site which is having the all configuration of Hadoop and MapReduce both. So core site.xml, when you open is core site.xml. So you have to add the configuration like this. So if you see here in the website, the core configuration is here. So you have to just change your username here. That's it. And remaining things will be the same. So you copy this and paste it here. Go here and paste in the notepad. So you will get this thing. When you get first time, you will get it like this. You will get it like this. So what you have to do, you have to copy paste it, this configuration here. You have to configuration, you copy paste it from here, copy, and then paste it. You have to paste it and then change your username. So mine is Arvind, but you have to change yours. So you have to save it and then save it. This is a one file. Second one is SDFS site. This one. So SDFS site.xml, when you open it, it is related to Hadoop distributed file system. So this file you have to go next to, and here is a SDFS site.xml. So this configuration you copy it and paste it here in the node. But here is again two places you have to change. One is a DFS data dir and one is a DFS data dir is a name node, and one is a data node, which we are talking about. So here is you have to change your username. And next one is map_site.xml. So here is no change, just you have to copy paste. So map_site.xml. So this map_site.xml as it is, you copy paste it from map_site. So two files you have to do changes, core site and SDFS. map_site.xml as it is, you copy paste it. And last one is yarn_site.xml. So yarn_site.xml is the last file. This file you have to edit. So when you click and select, and this file configuration you have to change from here, yarn_site.xml. So once this all configuration done, then now you have to do your name node format. Okay, I cannot do that because otherwise my data will go away. Okay, so you have to, once you do your name node format, SDFS name node format command, after that you can start your Hadoop service. So how to start the Hadoop service? Two ways are there. Either way is, like one way is start -all.sh you do. Now my 5 services are going to start. The first service is name node, then data node, then secondary name node, and then resource manager and node manager. Okay. And if you start like this, dfs.sh and yarn.sh. So dfs.sh will start your 3 services, name node, data node, and secondary name node. And yarn service will start your resource manager and node manager. So either you can start by 2 command or you can start by 1 command. Okay, same like a stop you want to do. So same commands are there. For stop dfs.sh, stop yarn.sh, or stop all.sh. When you do stop all.sh, it will stop all 5 services in a one single command. If you do stop dfs.sh, it will stop only 3 services. And stop yarn will stop the resource manager and node manager. So how to verify how many services are running? So this JPS command is there. So once your this start -all.sh is done, then you can run this JPS and verify your all 5 are coming or not. So now I write JPS. So when I do JPS, I can see my all 5 services are coming. So it means my Hadoop is running. If I want to see my Hadoop is running on the UI, so there is a localhost UI is there. So when I run this localhost UI, I can see the user interface of Hadoop file system. So here you can go utility. So you can see the cluster information, like this is a cluster ID. Okay, this is, so everything is managed by the Hadoop only. Okay, and how many live node are there? So live node is a one only because this is a one single machine. It is not a cluster of multiple nodes. So browse file system, you go, and here you can see when you click on go, so it will be showing the root path. Okay, so my root path, I have created some directories file, right? So it is showing here. So if I want to see the Hadoop file system command line, so you have to use prefix Hadoop fs -ls and then slash. Slash is for root. So you will see the Hadoop file system. Can you see the same thing is there? This is one same. This one and this one is same. This is directory, D for directory. Okay. If you simple do ls, it is a Unix file system. If you do Hadoop fs -ls/, it is showing the Hadoop file system. Okay. It is Hadoop file system. Suppose I want to create a directory in my Hadoop file system. So Hadoop fs -mkdir command is there. And then you say /test new. Okay. So when I do this, and again I do Hadoop fs -ls, I will see test new. I'm able to see test new, right? This. So this is a Hadoop developer command. Whatever command I was talking about, these are the command which is dealing with your Hadoop file system. How to copy the data. So whatever doing analytics you are going to do in Hadoop, first of all, your data should be there in Hadoop file system. Because if the data is there in my Linux file system, in Windows or Linux file system, I cannot do the analytics. I need my data should come into my Hadoop file system, then only I can do my analytics by using the Hadoop tool. Okay. Anyone has any questions? Okay. So I will share the recording and I will share the notes and I will share the PDF. Okay. So you can go through it. Okay. So next I have to start the commands. Okay. So you can go through the command. Okay. I will give the video of the command so that you can see all the commands in the advance. Okay, so you can prepare it. Okay. Yeah. Okay, thank you. Thanks, everyone.
Thank you.